Hello everyone. Today we are going to learn coprime numbers. So let's have a look at definition of coprime numbers. Two numbers are called as coprime if one is the only common factor between them. A and B, these two numbers are called as coprime if one is the only common factor between them. Or the another definition of coprime numbers is A and B, these two numbers are coprime if highest common factor, that is HCF of these two numbers is 1. Okay everyone, so if A and B are coprime, then 1 has to be the only common factor between them. If A and B are coprime, then HCF of A and B has to be 1. Okay everyone, coprime numbers are also called as relatively prime numbers. Okay, so now let's see how we can define, how we can identify whether two numbers are coprime or not. Okay, let's take first example. First example is 15,33. Okay, so over here let's have a look at factors of 15. Factors of 15 are 1, 3, 5 and 15. The factors of 33 are 1, 3, 11 and 33. So over here we can see that common factors of A and B, that is common factors of first number and second number, that is 15 and 33, is 1, 3. So from this we can see that this pair is not a coprime pair. Okay everyone, because common factor is 1 and 3, we want common factor to be only 1. So this pair does not represent coprime pair. Let's have a look at one more example. 15, 49. Let's have a look at factors of 15. 1, 3, 5 and 15. Let's have a look at factors of 49. 1, 7 and 49. So over here we can see that common factors is only 1, and that is why 15, 49, these two numbers represent coprime numbers. Now after this, let's have a look at few more examples of coprime numbers. Okay, let's have a look at 16, 35. Is it a coprime pair or not? Let's have a look at it. Factors of 16, 1, 2, 4, 8, 16. Factors of 35, 1, 5, 7, 35. So over here we can see that factors, common factors is only 1. That is why they represent coprime pair. Let's have a look at one more example. 20, 63. Okay, let's list down all the factors of 20. 1, 2, 4, 5, 10 and 20. All the factors of 63. 1, 3, 7, 9, 21 and 63. Over here we can see that common factor is only 1. That is why 20, 63 is a coprime pair. Now after this there are some typical examples of coprime numbers. Okay, so let's start with first one. 15, 16. Can I say 15, 16 are coprime numbers? Yes, they are coprime. After that 20, 29 also coprime. Okay, and after that 34, 35 also represent a pair of coprime numbers. So from this what we can say that take any two consecutive natural numbers. Take any two consecutive natural numbers, they are always going to be coprime. Okay everyone. Now let's have a look at some more examples of coprime numbers. 25, 27. Yes, they are coprime. After that 33, 35 is also coprime. Okay, after that 49, 51 is also coprime. Okay, so from this we can say that take any two consecutive odd numbers. Okay, take any two consecutive odd numbers, they represent a pair of coprime numbers. After that 7, 23 represent coprime pair. 29, 37 is also coprime pair. 11, 19 is also a coprime pair. So from this we can say that take any two prime numbers. Take any two prime numbers, they always represent a coprime pair. After this, let's have a look at a question. Okay, now my question is, how many natural numbers below 40 are coprime with 40? Okay everyone, how many natural numbers below 40 are coprime with 40? So first of all, let's do this question manually, and there is a separate formula to find out the answer of this question. Okay, so first of all, let's understand what exactly this question is talking about. We want to find all the numbers which are below 40 and which are coprime with 40. Okay everyone, so let's do this question manually. First of all, we can say that 1 is coprime with 40. Okay everyone, 2 is not a coprime with 40. Okay, 3 is coprime with 40. After that 5 is not, 4 is not, 5 is not, 6 is not, 7 is S, 8 is not, 9 is S, 10 is not, 11 is S. Okay, 12 is not, 13 is S, then not 14, 15, 16, 17 is coprime with 40. Okay, After that 19 is coprime with 40. After that 21, 23, 27, 29, 31, 33, 37 and then 39. Okay, these are the numbers which are below 40 and coprime with 40. You can say this count is how much? This count is 16. Okay, so total there are 16 numbers which are below 40 and which are coprime with 40. Okay, so every time we do not need to do manually. Okay, we are having a separate formula. Okay, we'll have a look at that formula, but before that let's have a look at one more question. Now the question is, how many natural numbers below 45 are coprime with 45? Okay, so first of all let's do this manually. How many natural numbers below 45 are coprime with 45? We can say 1 is coprime with 45. After that 2, 3 is not a coprime with 45. Okay, 4 is coprime with 45. Okay, 5 is not, 6 is not, 7 is yes. Okay, 8 is yes. After that 11, 13, 14, 16, 17. Okay, after that 19, 20 is not, 21 is not, 22 yes, 22 is a coprime. Okay, with 45. Then 23 is coprime with 45. Okay everyone, 24 is not, 25 is not, 26 is yes. Okay, 27 is not, 28 is yes, 29 is yes, 30 is not. Okay, then after that 31, 32, 34, 37, 38, 30, 38, 39 is not a coprime with 45. 3 is a common factor. Okay, then 41 is a coprime with 45. Then 43 is also coprime with 45. And finally 44 is a coprime with 45. This is 44. Okay, not 45. Let me correct this. This is 44. Finally 44 is coprime with 45. So total how many numbers are there which are below 45 and coprime with 45? Total there are 24 numbers. Total there are 24 numbers which are below 45 and coprime with 45. Okay everyone, so every time we are not supposed to do manually like this. Okay, I just showed you to understand the method, to understand which kind of numbers we are talking about. Okay, now after this let's have a look at a formula. The first step is the prime factorization. Okay, so if we want to find out how many numbers below n are coprime with n, then first step is we are supposed to do the prime factorization of n. Okay, so let's say the prime factorization of n is a to the power p into b to the power q into c to the power r into so on, where a, b, c are prime numbers. So over here the problem statement is how many natural numbers below n are coprime with n. Okay, how many natural numbers below n are coprime with n? This concept is called as Euler of n. Okay, this concept is called as Euler of n. How we represent it? We represent it by using sign phi of n. Okay everyone, how many natural numbers below n are coprime with n? This concept is called as Euler of n. We represent it by using phi sign, that is phi of n. The formula to find out this is n into 1 minus 1 divided by first prime factor, that is a, into 1 minus 1 divided by second prime factor, that is b, into 1 minus 1 divided by third prime factor, that is equal to c. Okay everyone, so the Euler of n is equal to n into 1 minus 1 by a into 1 minus 1 by b into 1 minus 1 by c and so on, where a, b, c are prime factors of n. Okay, so how to use this formula? Let's have a look at it. Let's apply this formula on the first question, that is 40. Okay, our first question was for 40. The prime factorization of 40 is 2 to the power 3 into 5 to the power 1. So let's find Euler of 40. Euler of 40 is going to be how much? 40 into 1 minus 1 by 2 into 1 minus 1 by 5. That is 40 into 1 by 2 into 4 by 5, and that is nothing but 16. So from this we can see that there are 16 numbers which are below 40 and coprime with 40. After this, let's take example 45. Okay, 45 is nothing but 3 square into 5 to the power 1. This is the prime factorization. So Euler of 45 is equal to 45 into 1 minus 1 by 3 into 1 minus 1 by 5. That is equal to 45 into 2 by 3 into 4 by 5, and that is nothing but 24. So from this we can see that there are 24 numbers which are below 45 and coprime with 45. Okay everyone, now let's have a look at the next concept. The next question is find sum of all the natural numbers, okay, which are below 40 and coprime with 40. Find sum of all natural numbers which are below 40 and coprime with 40, okay. Now few slides ago we saw how many numbers are there which are below 40 and which are coprime with 40, okay. So these are the 16 numbers which are below 40 and coprime with 40. Over here you can see that for every number out of these 16 numbers, okay, for every number out of these 16 numbers there is some another number such that their addition is 40. Now let's have a look at it. What I'm talking about is for every number out of this 16 number, okay, there is some another number such that their addition is 40. For example, 1 plus 39 is 40, 3 plus 37 is 40, 7 plus 33 is 40, and so on. 19 plus 21 is 40, okay. So for every number out of these 16 numbers there is some another number such that their addition is 40, okay. Thus over here we can see that out of these 16 numbers there are 8 pairs, okay. Out of these 16 numbers we can form 8 pairs having addition 40, okay. The sum of all these 16 numbers which are below 40 and coprime with 40 becomes how much? 40 into 8, because there are 8 pairs of addition 40. So the sum becomes how much? 40 into 8, that is equal to 320. Now, after this, the question is find sum of all natural numbers which are below 45 and coprime with 45. Okay, everyone, same question we need to do with 45 now. Now, as we saw earlier, total these are 24 numbers. Okay, these are 24 numbers which are below 45 and coprime with 45. Okay, these are 24 numbers which are below 45 and coprime with 45. You can see that for every number out of these 45 numbers, ignore this. For every number out of these 24 numbers, there is some another number such that their addition is 45. Okay. For example, 1 plus 44 is 45. 13 plus 32 is 45. Okay. 17 plus 28 is 45. Likewise, for every number out of these 24 numbers, there is some another number such that their addition is 45. Thus, we can see that over here there are 12 pairs having addition as 45. Okay, so the sum of all these 24 numbers which are below 45 and coprime with 45 is going to be how much? 12 into 45, because there are 12 pairs having addition 45. So the sum of all these 24 numbers becomes how much? 45 into 12, that is equal to 540. After that, let's generalize this concept and let's have a look at formula for this. The problem statement is sum of all numbers. We want to find sum of all numbers which are below n and coprime with n. Okay, the formula is going to be what? Euler of n divided by 2 into n. Okay, if we want to find sum of all natural numbers which are below n and coprime with n, the formula is going to be how much? Euler of n divided by 2 into n. Okay, after that, let's have a look at the next question. The next question is in how many ways 40 can be expressed as sum of two relatively prime numbers. Okay, in how many ways we can express 40 as sum of two relatively prime numbers. As we saw earlier, these are 16 numbers which are below 40 and coprime with 40. Okay, now over here we can see that for every number out of these 16 numbers there is some another number such that their addition is 40. Okay, so total how many pairs of addition 40 we can form? Total there are 8 pairs of addition 40. Okay, so the answer is 8 ways. Let's have a look at another question. In how many ways 45 can be expressed as sum of two relatively prime numbers? Okay, so these are 24 numbers which are below 45 and coprime with 45. Over here you can see that out of these 24 numbers, for every number there is some another number such that their addition is 45. So how many pairs are there such that their addition is 45? Total there are 12 pairs in which the addition is 45. So in how many ways we can express 45 as sum of two coprime numbers? In 12 ways. Okay, everyone, so let's generalize this concept. Over here the problem statement is the number of ways in which n can be expressed as sum of two coprime numbers. Okay, so the formula to find out this is phi of n divided by 2. Okay everyone, the formula is phi of n divided by 2. Now let's have a look at next concept. The next concept is, in how many ways 600 can be expressed as product of two relatively prime numbers? In how many ways 600 can be expressed as the product of two relatively prime numbers? Over here, first step is prime factorization of 600. Okay, so let's do prime factorization of 600. 600 is nothing but 25 into 24. That is 25 into 8 into 3. That is nothing but 2 cube into 3 to the power 1 into 5 square. Okay, the prime factorization of 600 is 2 cube into 3 to the power 1 into 5 square. Now we are supposed to express 600 as a into b. Okay, we are supposed to express 600 as a into b, where a and b, these two numbers are supposed to be co-prime numbers. Okay everyone, now let's take an example. If I write a is equal to 2 square into 5 square, okay, and b is equal to 2 to the power 1 into 3 to the power 1. Okay everyone, 600 is nothing but 2 cube into 3 to the power 1 into 5 square. We can split this number as 2 square into 5 square into 2 to the power 1 into 3 to the power 1. Okay everyone, the first bracket represent value of a and second bracket represent value of b. Now tell me, are they coprime? Is a and b, this is a coprime pair? No, this is not a coprime pair, because 2 is a common factor between them. Okay everyone, so this pair is invalid pair. Okay everyone, I hope everyone understood this. These two numbers are supposed to be coprime, but over here 2 is a common factor between them. Okay, so now how can we solve this question? Let's have a look at it. First of all, let's solve it manually and then we'll have a look at a formula. Okay, 600 is equal to 2 cube into 3 to the power 1 into 5 square. We are supposed to express 600 as a into b, where a and b are coprime pair. Okay, so the first possibility is the value of a is 2 cube and the value of b is 3 to the power 1 into 5 square. Yes, this is a coprime pair. Okay, now after that, first bracket means first number, second bracket means second number. Okay, the second possibility is 3 to the power 1 in first bracket, that is the value of a, and the value of b is 2 cube into 5 square. Okay, so first bracket is a, second bracket is b. In these two brackets the common factor is only 1, that is why they represent a coprime pair. Okay, the third possibility is first bracket is 5 square, that is value of a is 5 square and the value of b is 2 cube into 3 to the power 1. This is also coprime pair. And the fourth possibility is 600 is equal to 1 into 2 cube into 3 to the power 1 into 5 square. Okay, first bracket is a, second bracket is b. So over here a comma b represent a coprime pair. Okay, is there any other pair? No, there is no any other pair. So in how many ways we can express 600 as a product of two coprime numbers? So there are total 4 ways of expressing 600 as a product of two coprime numbers. Okay everyone, so now let's have a look at formula for this. Over here the problem statement is the number of ways in which n can be expressed as product of two coprime numbers. The formula is 2 to the power, okay, 2 to the power number of prime factors minus 1. Okay everyone, for example, the question we saw earlier is for 600, in how many ways 600 can be expressed as product of two coprime numbers. Okay, so the prime factorization of 600 is 2 to the power 3 into 3 to the power 1 into 5 to the power 2. So over here we can say that how many prime factors 600 is having? Total 3 prime factors 600 is having. Which one? 2, 3 and 5. These are 3 prime factors. Okay everyone, now how many prime factors are there? 3 prime factors are there. So in how many ways 600 can be expressed as product of two relatively prime number? The answer is 2 to the power 3 minus 1, that is 2 to the power 2, that is equal to 4.